Okay, it's 5 p.m. here in Paris, so it's time to start. Hello everyone, welcome and thank you for joining us today. My name is Noémie Remilly and I am the event coordinator at SBG Systems. Today, we are very excited to present you our webinar entitled PPK UAV Photogrammetry with DJI Phantom, the optimal workflow to reduce ground control points and maximize return on investment. So today, we will have the pleasure to hear and to learn from Alexis Guinamard, Chief Technology Officer and co-founder of SBG Systems, and Raphaël Siriani, Chief Software Architect and co-founder of SBG Systems. So Alexis will start with an introduction on our latest INS development for UAV photogrammetry and LiDAR. Then Raphaël will discuss if precise image geotagging is a standard for UAV photogrammetry. Then he will explain why PPK over RTK is the best choice for photogrammetry jobs. And then we will attend a workflow demonstration with Qinertia, PIX4D, and DJI. And to conclude, we will have a Q&A session at the very end of this webinar. So yes, if you have any questions during this webinar, please type them into the chat window. We will address some of them during the Q&A session. We also have a team ready to answer your questions by chat during the webinar, so please feel free. But without further ado, I will now hand over to Alexis for a presentation of the latest INS development for UAV photogrammetry and LiDAR. Alexis, the floor is yours.
Thank you, Noémie. It's a pleasure for me to introduce you very briefly our company and also all the products that we can deliver to these markets. First, for those who are not so familiar with SBG Systems, we are a French leading supplier of orientation, stabilization, and navigation solutions. We've got an international presence with headquarters in France, but we also have subsidiaries in USA, in Singapore, and a wide range of distributors all over the world. We have more than 10 years of expertise in all survey markets and a wide range of customers in 40 countries and more than 30,000 inertial sensors on the field so far. Regarding our expertise in survey markets, it's important to know that SBG Systems was working for many years now in performance-driven, in very high accuracy-driven markets, such as hydrographic survey or mobile mapping. And we are now pushing our technology to the UAV markets to address a much wider range of users. So regarding the UAV markets, the UAV survey markets, we can basically split the market in two different technologies. Raphaël will dive very deeply with the photogrammetry market. But just as an introduction, I wanted to tell that photogrammetry is a highly cost-effective solution for UAV survey. This technology strongly relies on camera, but also on vision algorithms like photogrammetry. And it's really CPU and GPU intensive, so it means that this could be the limiting factor for large survey areas. But this can be greatly improved by adding an RTK or an IMU on board the UAV. On the other hand, you've got the LiDAR mapping market, which is typically a much higher cost solution, but it operates also in different conditions, very challenging conditions like over dense vegetations, to survey power lines and other difficult tasks for photogrammetry. So these two markets are not really overlapping that much. And also this technology does not require that much CPU or GPU on the processing side. However, the LiDAR mapping strongly relies on the INS performance and repeatability. So in that case, it's really mandatory to have a very good inertial sensor. That's where we can provide a wide range of solutions, ranging from the basic IMU sensor sets to a full-featured inertial navigation system. And of course, we also provide a post-processing software, Qinertia, but I don't go that much with Qinertia. Raphael is going to tell you much more about that. Regarding the hardware, we can have a brief discussion about the Ellipse sensor, which would be a perfect start if you want to build in your own photogrammetry application, or even your own entry-level LiDAR payload or LiDAR mapping system. The Ellipse is a perfect match for this kind of application, with an excellent roll and pitch performance, excellent heading performance with operation in a single or dual antenna setup. The system is also able to provide an RTK position with 1 centimeter accuracy, and it embeds an industrial grade IMU capable of operating in a wide range of temperature. It's also ideal for a tight integration with an OEM product, which is really small, as you can see here, and it's compatible with our Qinertia post-processing software. But if you want to reach the best performance level, you can also consider our Quanta solution, which be a perfect match for high performance LiDAR mapping applications. You've got 2 performance levels. You've got also some extra capabilities compared to the Ellipse, like NTP or PTP time servers to synchronize the LiDAR payload, for instance. You also have an embedded data logger to allow very smooth workflow for the post-processing, and also a built-in Ntrip client for easy correction access. But now I will just leave Raphael explaining you how the precise image geotagging is a standard for UAV photogrammetry. Back to you, Raphael.
Thank you, Alexis. I'm very excited to spend the next 40 hours with you, 40 minutes, with you, and to talk about photogrammetry and most importantly, post-processing. So before we go to the post-processing part, I would like to very briefly introduce what is photogrammetry and how does it work, and also talk about, let's say, traditional photogrammetry with ground control point. Then I will more focus on the PPK, PPK and RTK choices. And finally, we will have a quite extensive demonstration of Qinertia with PIX4D and DJI Phantom 4 RTK UAV acquisition. So you can have an overview of the whole picture and workflow. So photogrammetry, basically, we will be using a lot of pictures to be able to create 3D maps, 3D buildings, 3D objects. We can create auto-rectified 2D maps. We can create digital elevation models or digital elevation surface models. And we can also have more fancy applications with different cameras, such as hyperspectral cameras. And how does this work? It's quite simple to understand. In fact, we just use several pictures. And thanks to all these pictures, we can reconstruct a 3D point cloud with a basic triangulation computation. And to do so, we need a very precise orientation and a very precise position of each picture. So there are several ways to be able to find the precise orientation and the precise position of each picture. The most common one is using only photogrammetry algorithm. So basically, we will be detecting some features in the pictures and find the right alignment and position. But more and more, we are relying on pictures that have built in a very accurate position using RTK or PPK, and also an orientation using onboard IHRS or INS or IMU to be able to help the photogrammetry algorithm. So the typical workflow for photogrammetry is acquiring some ground control points, then doing the picture acquisition. Sometimes, depending on your workflow, you could post-process the GNSS data from the UAV to be able to get a very accurate post-process position for each picture. So it's optional. Sometimes you are using real-time RTK corrections. Then you put all the pictures and position orientation of the pictures in the photogrammetry software to compute the 3D point cloud. And finally, once you've got the 3D point cloud, you will do the business work itself using dedicated platforms such as Altea or Drone Deploy, for instance. Just for the record, we have evaluated our solution with the following photogrammetry softwares: PIX4D, MeetShape, and UAS Master from Trimmer. So how does traditional photogrammetry work? So basically, the photogrammetry software will only use pictures to be able to estimate accurately the picture orientation and the picture position. So as I said, using features. So you can see on the bottom right corner an example of a feature detected by the photogrammetry software. And also the photogrammetry algorithm during the first initial step, that is the optimization, bundle adjustment step, all the camera internal parameters will be refined, such as the distortions and the focal length and all that stuff. So to do so, the photogrammetry software needs to detect a lot of features. So you need a lot of overlapping between the pictures, and also you need in the pictures themselves some very easy to identify features. So if you are doing survey over a crop field, for instance, it could be tricky because everything can be mixed up. Then you definitely need ground control point because you have to constrain the estimation just to make sure that you find the right scale, the right model scale, as well as the right orientation and position, because you have to place it on the earth. And you also, the photogrammetry algorithm also need a lot of ground control points to be able to find the right estimation. Otherwise, it could mix some parameters. It could mix the orientation with the position, with the internal camera parameters, for instance, because it's basically just a very large least square estimation. So you can have some issue if you don't have enough ground control point with traditional photogrammetry. If you can provide just a raw picture position and orientation, you can still benefit from it and reduce a lot the required overlapping, and as a result, the number of pictures for a mission, and thus reduce the processing time. And we'll see that a little bit later. So let's talk about two typical surveying applications, having a square mapping and having a corridor mapping. If you do square mapping, typically you will need 5 ground control points, even if 10 are most of the time recommended. And just to give you some metrics, you will need at least 14 ground control points according to PIX4D to be able to reach the same level of accuracy than a RTK or PPK capable GNSS solution, that is roughly 2 centimeters or 0.5 feet. If you do corridor mapping, so it's basically mapping in long straight lines, you will need a lot of ground control points evenly spaced and distributed around the mapping area, and it could take a lot of time to set up all the ground control points. So basically, what is a ground control point? You have to place an artificial marker or draw it on the ground. Then generally you will be using GNSS receiver with another GNSS base station to do RTK correction and get a very precise position. You have to note this position, and then you should input in the photogrammetry software for each ground control point the right position. So it's quite consuming, and it could be quite complicated if you would like to automate this process and if you have a lot of large area to survey. And a ground control point, you sometimes need even much more ground control points to be able to reach very good accuracy. If you have hills or mountains, at least a lot of vertical differences between different areas, you will need more ground control points. Also, when you have done the acquisition, you have to retry the ground control points, and you know that drawing a ground control point is less accurate than using artificial ground control points. But ground control points, it's perfect if you are always doing the same acquisition over and over again, because you just place them, measure them, and that's it. But sometimes it could be also impossible, just impossible to place a ground control point. So if you have private properties, cities, if it's a remote location, difficult to access, and also sometimes dangerous areas. So I have to admit my example with the volcano is a little bit extreme, but still you get the point. It could be quite complicated to access all the areas and correctly place the ground control point. And up to now, it's always not so easy and not always guaranteed that you can have automated workflow with ground control points, even if more and more you are able to have software that can detect and match the ground control points by themselves, but still it's not always reliable and easy to implement. And because you have a lot of different tasks, materials, equipments, it could be quite error prone. So more and more server users are using RTK or PPKs. So basically the idea is to geotag each picture with a precise position and at least, let's say, a rough orientation. So you get a 2-3 degree orientation on the picture itself and a very accurate position of the picture. And then the photogrammetry software can will still have to refine some parameters, but can rely on the picture position to optimize the bundle adjustment and optimization process. And the photogrammetry software will have to refine the omega phi kappa, so the picture orientation, to better than 0.01 degree. And also, you still need the photogrammetry software to refine the internal camera parameters, because you know that from one acquisition to another, it can slightly change over time. So it's still very helpful, but the position of the picture is very accurate. And thanks to that, the photogrammetry algorithm is much more efficient to find the right picture orientation and the right camera internal parameters. Also, because you have a correct picture position as well as roof picture orientation, you can reduce the overlapping needed to serve specific areas. And you can also sometimes make sure that you can do the survey even if you have some difficult environments, such as the field crop example, for instance. Even if you are using RTK or PPK, most of the time you will still need at least one ground control point, mainly to do some QC, because your end user will need a sort of guarantee that you have the right position, the right datum conversion, the right projection, geoid parameters, and all the stuff. So even if you use PPK or RTK, most of the time you will be requested to get at least one ground control point. And sometimes in very specific areas, it's recommended to have 2-3 more ground control points to just surround the overall server area. But thanks to RTK PPK, you can survey very large scale areas, and you can also set up fully automated workflows and process, and that's mandatory if you would like to achieve a lot of processing jobs. So how do we do the RTK PPK precise geotagging? So basically, most of the time, if we take the example of the Phantom 4 RTK DJI UAV, you will get a precise position at the GNSS antenna itself. So it's called APC, antenna face center, and you will have to relocate this position to the camera center, so the CMOS sensor itself, because the photogrammetry algorithm needs the picture orientation and the picture position, and not the GNSS antenna position. So to do so, you will always need at least a let's say, rough RHRS accuracy, so a rough roll, pitch, and heading angles to be able to do the relocation. And so if we take the DJI example, it's embedding in the gimbal a low-cost roll IMU that is able to provide a very rough roll, pitch, and heading information. And if we do a little math, we see that with just a 10 centimeter lever arm, that is roughly what we could find on a DJI UAV, even with very low accuracy IMU that delivers roughly 6 degrees of heading accuracy, we get 1 centimeter of sort of offset or errors on the position picture just due to these relocations, just to give you some numbers. But still, we have to do this relocation. So there are two ways to do it. The first one is full INS way. So if you use a full INS, such as the products we also offer, ElipseD or Quanta, for instance, the INS will do the job automatically, and you will get a very precise orientation as well as a position directly at the camera center. And thanks to that, because you will not have to re-estimate the picture orientation, you can survey everywhere, such as crop fields, because you can disable in the photogrammetry software completely the bundle adjustment, camera external parameter estimation. But still, you will most of the time keep the camera internal parameter estimation. If you go for a GNSS only approach, such as the one you have on the DJI Phantom 4 ATK, in this case, the UAV will deliver the position at the GNSS antenna or the PPK software at the GNSS antenna. And thanks to a built-in low-cost RHRS in the UAV, we will do the relocation to the picture center itself. Of course, the photogrammetry software will have to do more work, such as finding the precise picture orientation, but it will rely on the precise picture position to do this job much more efficiently. So back to you, Noemi, for a few numbers, interesting figures.
Yes, thank you very much, Raphael. So we will now take a minute to analyze the answer you gave us during the registration process. So first of all, thank you very much for all your answers. It is very interesting material to comment on. So the first question was, how many sites, jobs, do you survey per year? So what we got from your answers is that for a large majority of you, it is less than 50. The second question was, which survey technique do you mainly use? So we can see that most of you already use UAV photogrammetry, and the results are quite close between the ground control point technique and the RTK PPK one. And finally, the last question was, what are the main issues you face when performing a UAV photogrammetry project? We received many feedback on that question too, so thank you so much. And what we can say is that the issues that have been the most often mentioned are the issues linked to environment, accuracy, project duration, data transfer, computing, post-processing, and of course, the ground control points. So Alexis, can you tell us what are the main insights you keep from this data?
Well, I would say that these are really interesting figures. First, I would comment that we see that the market is still really growing with many new actors. So that's for me a very good insight. But also some of them are already being more structured with daily surveys. So it's then really critical for a company that is starting their operation to find professional solutions that do not put a too high price pressure. That's I think that's a key point, and dealing with new business models such as monthly subscription can really help on that side. But then once the solution should also be able to scale with your need, meeting stringent technical requirements. Regarding the survey techniques, what we see is that, of course, the surveying, the traditional survey with GCP is still the most common technique, but we really see that RTK and PPK is getting more and more popular with almost the same proportion of as GCP. And finally, regarding the different pain points that have been highlighted, they are mostly concerning the workflow involving the ground control point setup, computational steps, and also the accuracy issues are often related to this long chain of error budgets that require a very, very high rigor in your operation. So to sum up, in my opinion, I think this really confirms that there is a very high demand for getting solutions of trust that drastically ease the photogrammetry process.
Okay, so thank you very much. Thank you very much, Alexis. It was very interesting, and let's continue. Now we will be talking about post-processing kinematics over real-time kinematics, and we will see why it's much easier, in fact, much more reliable than using real-time kinematics. So before I dive into post-processing, a very short introduction of ATK. So real-time kinematics, it means that you have a base station that it broadcasting in real time correction data to your UAV, and your UAV is receiving the correction data to be able to compute ATK fix. So it's ATK fix will deliver 1 to 2 centimeter accuracy. So it means that you have your base station that has to be correctly set up. You don't have to, you should not mix up with the base station position, the base station antenna configuration, and all that stuff. Most of the time, what you will do is to place the base station using VRS networks, to locate the base station using a VRS network, because you have to, let's say, onshore the base station to the coordinate system you are working in. So if you do so, you need VRS access with a cellular modem. You also need a subscription to the VRS. So for the one who don't know what VRS is, it's a virtual reference station. It's network RTK and RTK, all that stuff. So basically you have to get a subscription to access surrounding base station corrections to be able to precisely find your base station position. So still, yeah, you see that it's starting to be complicated. You need a VRS modem, VRS access, cellular modem. You can't survey in remote location because most of the time you will not get PPP nor cellular modem access. And so you will not be able to get your base station position. So you will not be able to get absolute RTK position from your UAV. So you will be in fact stuck in this case. Also on the UAV side itself, you are totally relying on the UAV RTK engine. So it depends on which GNSS receiver has been used in the UAV. And sometimes you can have some issues such as not getting so much RTK fixed position. You can have RTK floating position because the RTK engine is not perfectly tuned. Or you can have also sometimes some issues between the base station and the UAV radio link. If you are doing a lot of surveying cities, for instance, if you have hills or vegetation, you can lose quite easily the radio link between the base station and the UAV. And also, we have seen a lot of issues between the base station and the UAV GNSS receiver compatibilities. So sometimes you have some incompatibilities, and it's not always very easy to see because it could work, but not completely. So you could have a decreased accuracy or most of the time, a decreased reliability in the real-time GNSS solution, and you are not aware of it. So as you see, it's a quite complex setup with a lot of different hardware involved, a lot of operators, because you are relying on over a VRS provider, cellular modem provider, And if you make any mistake during ATK acquisition, in fact, you have very little ways to save a mission unless you do post-processing. So now let's talk about the post-processing stuff itself. So basically, you will just have your UAV that records raw GNSS observables. So it's all the information from the space vehicles directly, not the position, but really the information from the satellites. You will be also having a base station that is storing all the same information, so the same raw GNSS observables, and that's it. And then you will use a post-processing software after the mission to compute a very accurate position, PPK position. So regarding the photogrammetry, the most important point is to have a very accurate relative picture position, because you don't want noise in the position between each picture. If you have a noise between pictures in the position, it will decrease the photogrammetry optimization process, and it could create some sort of issue with estimated internal and external parameters. So you really would like to have the best picture position accuracy. And we are looking at very high accuracy, better than 1 centimeter here. So with PPK, you also get much more accurate position. We'll see that later. So for this first point, it's really interesting. Then with the PPK software, you have a lot of options to be able to get a precise position. You can rely on free CORS network. So CORS network, it's continuously operated reference stations. So most of the time you have nearby free CORS network. And thanks to the unique Qinertia virtual base station algorithm that I will describe later, you can extend a lot the CORS network coverage. For instance, we have a full coverage of the United States. You can also use your own base station. You can install your own base station nearby the surveying area. And then you can use Qinertia also to find the base station position very accurately if you have no other way to do it. So you don't even need a VRS access or modem access or whatever. You can use Qinertia to survey your base station position very precisely. So with a full post-processing software, in fact, you have a solution for all scenario and use case. Something that we don't recommend, however, is using a PPP solution to compute picture position directly. Even if you are looking at the latest PPP technologies with fixed ambiguities and all this stuff, for the one who are familiar with that, it's still not a good choice for UAV-based photogrammetry jobs. So clearly, the best setup is to use the raw GNSS from the UAV and either rely on the CORS network with Qinertia VBS or your own base station. And if you have to locate your base station precisely, use Qinertia to precisely survey the base station position. I will show all the steps in the demonstration later. Something also very important for you is that Qinertia is able to handle all the data transformation and geodesy stuff, because most of the time we see a lot of errors just coming from inconsistent datum and geodesy conversions. And of course, we also have a deep expertise in this field, so we can also help you on this. So now let's talk about PPK and Qinertia, how Qinertia deliver PPK. So Qinertia, it's a full-feature INS GNSS PPK software that deliver much more accurate position than RTK, because we are computing the solution in the forward direction and in the reverse, in the backward direction. And then we merge the two solutions together. And thanks to that, we are able to provide much more RTK fixed position. Sometimes if you look at real-time solution, you get RTK floating position that is not very accurate. And with Qinertia or PPK, in fact, you will get full all pictures with RTK fixed position. Also, Qinertia is supporting all GNSS manufacturers with a lot of advanced and interactive QC indicators, as you will see in the demonstration. And you have different processing modes, such as single base station, virtual base station, that I will cover later, and precise point positioning, PPP, for submission and to survey the base station position as well, as I said. And today, Qinertia is widely used for mobile mapping application and hydrography service for very high-end and demanding application when you are looking at the best accuracy. So just regarding virtual base station, it's something really interesting and it's not so common out there. So basically, virtual base station, it's an algorithm we have developed for the past 7 years, and we are using a lot of base stations together to create a network and to map all atmospheric corrections nearby your trajectory. We will also adjust the base station position automatically. And thanks to that, you can rely on a free coarse base station all around the world. And we increase RTK coverage dramatically because with VBS, with the virtual base station algorithm, you can have base station spaced by more than 100 kilometers, and you get the same accuracy as the RTK short baseline. It means that a lot of time you could have areas where you couldn't use, let's say, traditional post-processing solution. And in this case, Qinertia will be able to do the job thanks to the VBS algorithm. And also it's a full constellation solution. GPS, GLONASS, Galileo, Beidou, QZSS to get the best accuracy. Best solution for corridor mapping if you do long straight lines, because you don't have to place several base stations, just use the VBS and that's it. In Qinertia, we have worked very hard to get a dedicated photogrammetry module, and the idea is to simplify as much as possible the workflow. You just drag and drop the pictures within Qinertia. You get with Qinertia, we can timestamp the picture very easily. You can edit the timestamping and the match between the picture and the timestamp. So you don't need to edit Excel files and all this stuff anymore. You can preview the match. You can correct it. It's very nice to do it. And then you can set up all the EMU camera lever arms parameters, the camera bore sight angles, and all that stuff if you are using an EMS. And Qinertia will automatically update JPEG, EXIF, and XMP tags with the precise position and orientation. If you have a GNSS only solution, Qinertia will automatically apply the APC to CMOS lever arm offset we have talked about previously. And thanks to that, we are able to provide a direct support for DJI Phantom 4 RTK, as well as the latest Zenmuse P1 payload. So you just need to drag and drop the files from the Phantom 4 acquisition to Qinertia. Qinertia will read the raw data, GNSS data from the RTCM file, not the RENX file, because this one is error prone and we have seen some issues in it. Then Qinertia will read the MRK file that get for each picture the accurate timestamp as well as the accurate offset to apply. And Qinertia will compute a PPK solution and export updated JPEG files with the precise location, precise position of each picture, with the orientation and all the stuff, with the lever arm that has been taken into account. All the stuff are done automatically. And you will just need to drag and drop the files to PIX4D, for instance, to directly do your photogrammetry job. So it's very interesting because if you do multiple flights projects, and it's most of the time you do multiple flights projects, you just have to use Qinertia to process the flights and take all the JPEGs at once and put the JPEGs files in PIX4D, for example, and that's it. You can do the full photogrammetry job. It's also working with PIX4matic and US Master as well, and AGSoft, as I explained already. So before we go to the demonstration, last slide with photogrammetry with Qinertia, because we have very unique advantages I would like to pinpoint. When you do photogrammetry, you always have to do post-processing, in fact, because you post-process the point cloud. So if you post-process also the GNSS data, it's not an edit step. It's just having the right workflow and having automated workflows, but you don't really need to add a step. The PPK solution, it's the only way to get an accurate solution from the first picture to the last picture. You don't have convergence times and all that stuff. and you get also much more advanced and relevant quality indicators. So you exactly know what is going on, which accuracy you are getting. And Qinertia, because it's a professional solution with only algorithm that has been developed by SBG, we also deliver a consistent position, standard deviation, and quality indicator. And it's very important. So the photogrammetry software, when we say you have a picture with 1 centimeter position accuracy, the photogrammetry software will use this information, and he will know when a picture has the right position and when a picture has, let's say, less accurate position. Very important stuff. Also, Qinertia can address all your survey jobs, low-end, high-end, extremely high-end. So as soon as you need to process GNSS data from any brand and GNSS manufacturers, you can use Qinertia. So you can do all your ground control point, base station position, and anything else survey. So you can use Qinertia to know precisely where the ground control point is. If you still would like to use ground control point, you can use Qinertia to get the base station position. And as I said, you have free access to coarse base station, and combined with the VBS PPK algorithm we have, it's really interesting. Also very interesting, building CLI API if you would like to build automated workflows. And with PPK, you can fix most mistakes, and you can provide automated workflows to be able to serve large areas. Just do your survey, upload the data, do the processing, do your survey, upload the data, do the processing automatically. So now let's talk about a real life example. So we have done an acquisition with Jan de Nul, and we would like to thank Jan de Nul for sharing with us the results. It has been done using a DJI Phantom 4 ATK. It's one log, just to make it short for the demonstration, with quite a high overlap and a lot of ground control points. The idea was to be able to assess the quality. We will be using Qinertia to do the PPK processing and update the pictures with an accurate orientation and position. And we have been using PIX4D to do the point cloud processing without the ground control point, and then with the ground control point. And we use the PIX4D to assess the quality. So we see that without the ground control point, we still have a pretty good match. We have a very good hit on each ground control point that has been set up without using the ground control point in the solution. And just to give you some numbers, we have reprocessed the log with the ground control point enabled to see the mismatch. And we see that we have a maximum error of 3 centimeters on the z-axis for one control point, and most of the time we have less than 1 centimeter. So it means that with only PPK without ground control point compared to a solution with ground control point, we only have 1 centimeter to 2 centimeter error. So it demonstrates how accurate could be a PPK-based solution. Also, side note, we have been running a side-by-side test with the same log with ATK-based solutions, and we have seen some really interesting information. On the first part of the log, due to ATK convergence issue, you have, in fact, a lot of pictures that have a position that is offset, even if it's not reported in the standard deviation. So it disturbs a photogrammetry solution. And with Qinertia, obviously, you don't have this type of issues. So now let's have a demonstration of Qinertia and PIX4D. So I will fire up Qinertia, and I will create a mission using DJI data. So you see that it's a DJI typical acquisition with all the files from DJI. So I create a new project. I simply have to drag and drop my DJI data, DJI demo, let's call it this way, and that's it. It's a UAV. And we are doing all data importation. And now you see that we have only imported raw GNSS data because it's a GNSS only project, not an INS project. And now you see that we have a small hole in the GNSS raw data. It's because of a DJI bug. But thanks to Qinertia, we can see it, we can know it, and you have some feedbacks to know what is going on. We have also automatically downloaded the missing files, such as ephemeris, navigation file, all this stuff, so you don't have to bother about all this stuff anymore. And you have a trajectory preview, and I would just go to the next slide. And now I can handle all the base station stuff, use my own base station, use virtual base station. So for instance, here I have a virtual base station, a very large one that has been provided, but in this case, I will be using a nearby base station that has been placed, and I just drag and drop the Linux files to import the data and say, okay, I would like to use this one. And this base station, I would like to check if it has been correctly placed. So just select the datum for this one, and I can compute a PPP solution on the virtual base station itself. And I see that the base station position I had match quite well with the PPP solution computed from Qinertia, only 1 centimeter on the horizontal error, 6 centimeters on the vertical error. That is quite consistent because I only have 1 hour of observation. So it's perfectly consistent. And I just go ahead and continue my process. So I will start the post-processing itself. So I have started the GNSS only processing. You can see here the GNSS processing that is going on. And as you can see with Qinertia, we have a lot of feedbacks. You see here the real-time solution from the UAV. We can display a lot of different information, such as the position standard deviation, the number of space vehicles that have been used. And also we can display some statistical results that let you see very precisely the overall standard deviation, also what we call the separation between the forward and the backward solutions. We have a lot of advanced indicators here, and that's it. We have done the processing. So you see that we can even play the processing to see what is going on, see very precisely each point epoch accuracy. Now I can see that I have only ATK fixed, PPK fixed solution. I can also look at the position estimated standard deviation, 0.1 centimeter, very accurate. I can look at the separation, that is also very good. I can select this area, say, okay, I would like to analyze this area, and I see that I have a very, very consistent forward and backward estimation. And once I'm happy with the solution, I simply have, just let me show you this as well. Here you have a dedicated photogrammetry module for the DJI, and you see here that we have loaded automatically all the pictures from the DJI UAV. And we have a small icon here saying, okay, I have found a APC to CMOS lower arm offset, that is here. And I can, as I said, exclude some picture, exclude some events if I need to automatically edit the match if I have any missing pictures or invalid picture very easily. And once I'm happy with all the results, I can proceed to the export. We'll just be exporting all the pictures using MSL ellipsoid high. MSL high, sorry, and I'm doing the picture exportation. We have 244 pictures, and you see that it's quite a fast process to do the export. And that's it. We have done. We have all the pictures with updated EXIF, precise EXIF information, and we can now go to PIX4D to start the photogrammetry job itself. I also have a lot of information and reports to see exactly what has going on this dedicated job. And let's wait until PIX4D has started. So PIX4D has started, and now I just need to create a new project, DJI demo, that's it. And I have to just import all the pictures in PIX4D. That's it. And you will see that PIX4D is able to automatically read for each picture the correct latitude, longitude, altitude accuracy from the PPK solution is damn good, better than 1 centimeter, as well as omega, phi, and kappa angles. And in fact, you are ready to do the post-processing, the photogrammetry job itself. Obviously, I will not do it because still need a few minutes, let's say, of processing to do the full point cloud generation. But still, I have already done the photogrammetry processing just to show you the results. In blue, you have the ground control points. In red, you have all the pictures. And just to see what we have here, it's the spare point cloud. And if I take one ground control point, so you see here that we are not using the ground control point in the solution. We are just using the ground control point to make sure that without using the ground control point, we still have a hit a match. And you see that we have a quite good match for each ground control point. We are perfectly hitting the middle of the ground control point. So it means that the PPK only solution is perfectly fine, exactly the same level of accuracy as the ground control point solution. So just to sum up, Qinertia, it's a professional tool that is able to process GNSS and INS solution, hassle-free workflow, always get the same result and consistent results. It works with all base station, with all GNSS receiver, with everything. We have unique VBA single base station PPP solution. We have also an efficient CLI and API solution if you would like to automate completely the workflow. In this demonstration, I've shown the Qinertia GUI version, so you can see all the feedbacks we get. At Qinertia also, it will do all the hard work for you. It will automatically convert the files. We support directly binary files from Trimble, Novatel, Septentrio, uBlocks receiver, RTSM also. If you have Renex file, you just have to drag and drop the file. You never have to do some concatenation of files, some split of files. If you have 10 Renex files, just drag and drop the 10 Renex files and Qinertia will do the job for you. So it's really very easy to use and it will save a lot of headaches. Also, Qinertia, it's very actively developed. So we maintain the solution and we develop it and we add new features and evolution every year. And we are able to support all the parts of the software because we design the algorithm. So if you have any question, we can answer the question on the software itself, on the algorithm itself, on the accuracy you've got, and on everything, in fact. So thank you very much. And I will get back to Noemi for the Q&A session. Thank you so much.
Yes, thank you very much, Raphaël. So we have now a few minutes left for the Q&A session. So we received the first question. I think it's for you, Raphaël. I'm usually using Articalib to manually process my uBlocks receiver data. What more can I get with Qinertia?
So if you are using Articalib, first of all, you have to know that Articalib has more been developed for research and demonstration purposes. And as a result, a lot of stuff are very okay with Articalib, but a lot of other details are not well handled, such as some mismatch between the GNSS, the rover receiver, and your base station. You could have issues, especially if you are working with GLONASS constellations. Also, as we have seen in the demonstration, we have seen a lot of inconsistency between the position itself that is reported by Articalib and the estimated position accuracy reported also by Articalib. Sometimes you have Articalib saying you have a good position, but in fact, it's not a good position and it will mix it with the photogrammetry software. Something very important for us is to say when you have a good position, you have one, and when you don't have a good position, to also say it. Also with Articalib, we have seen a lot of users complaining about missing some fixed solution. Sometimes you have only Articalib float solution and you don't know why, and it's because of some issues regarding file conversion, specificities for each GNSS receivers, because you have to take into account each GNSS receiver specificities to be able to guarantee that you always have a good RTK solution. And finally, with RTK-lib, you don't have all the antenna handling, so you don't handle correctly all the antennas most of the time. Also, you don't have all the geodesy stuff, datum correction, projections, all that stuff are not handled. And you only have PPK. You don't have a really usable PPP nor a VBS. You don't have a VBS algorithm. You don't have access also to core base station automatically, as with Qinertia. Qinertia will download automatically all the missing files, such as navigation files. Qinertia will automatically download the surrounding base station. So, in fact, it's not only the algorithm, it's all the other stuff you have around it. If you use RTK-lib, most of the time, you will end up by changing some stuff in the Linux files or in some files, containing files, splitting some files. And it's not the case with Qinertia. Just drag and drop the files and that's it, do the processing with a reliable and consistent result over time. I hope it helps.
Okay, thank you, Raphael. I think I have another question for you. What GNSS receiver are compatible with Qinertia?
So as I said, all GNSS receivers, because we are running our algorithm on core base stations worldwide to make sure that we are correctly handling all GNSS receivers. So we have a built-in support for Trimble, Novatel, uBlocks, Septentrio, and DJI RTCM receivers. So it means that we can read directly the binary format. You don't have to convert the files to Linux. And it's much more efficient, it's much more accurate as well and reliable. For all of our GNSS receivers, you can either use RTCM or Linux inputs, but still, we have done a lot of work to make sure that we are compatible with all Linux GNSS receivers, such as Topcon, Hemisphere GNSS, Leica, just name it. We have a very huge database, and we have a continuous and automated test to check that Qinertia is still compatible with all GNSS receivers all around the world.
Okay, thank you, Raphael. I think I have a question for Alexis. Do you have a multi-base PPK solution for long corridor mapping?
Alexis? So
Alexis,
I will take this one. So yeah, indeed, we have a virtual base station built-in Qinertia, and virtual base station is typically done for that. We will use several base stations to be able to create an area in which we will map and estimate all atmospheric corrections. And in this area, you will be able to get a very accurate short baseline-like PPK solution. So it's much better than having a multiple single base station algorithm. That means that you have one base station, your rover, and then when you move to next base station, you switch to the next base station and then to the next base station, because in this case, you can have some jumps and some issues when you are in between the two base stations limits. With our algorithm, we do a full mapping of the area, and thanks to that, you get a perfectly fine RTK fixed solution. And we have run some tests, and we were able to get more than 600 kilometers of corridor mapping. So it's obviously not on a UAV, it was a helicopter and a plane. We ran two tests. And we used 20 base stations to do the trajectory, and we get 100% of RTK fixed solutions for this 600 kilometers long straight lines, just to give you some numbers.
Okay, thank you. And we will take quickly a last question. Could you give numbers? How more accurate is PPK solution versus RTK solution?
So in fact, it's not is PPK or RTK more accurate. It's more with PPK, you get roughly twice the accuracy as RTK, but most importantly, you get a reliable solution. Most of the time with RTK, you have some areas or some photos in your acquisitions that are not with a RTK fixed solution, because you have outages, because on the radio links, because you have GNSS disturbances, because you have bugs in the GNSS RTK algorithm, or mismatch between the base station and the rover, the UAV. With PPK, we guarantee that you will get always RTK fix, PPK fix solution. So you always get the best accuracy from the first picture to the last picture, because you don't also have the convergence time you need with RTK, because PPK is doing a forward and backward computation, then merge both solutions. So you don't have any convergence time. So it's a very important stuff. If you lost on a RTK the radio link between the base station and the UAV, the RTK algorithm will need some time to reconverge to a RTK fixed solution, and you don't have this type of issues with PPK.
Okay, thank you, Raphaël. So we received many questions during this webinar. Thank you very much for that. But unfortunately, we don't have the time to answer all of them now. But don't worry, we will come back to you soon by email to answer all the remaining questions. So our webinar is now coming to an end. Thank you everyone for joining us today. We hope you enjoyed this webinar. And for your information, you will receive the recording of this session tomorrow.
Thank you very much, Noémie.
You can.
And thank you all.
Yeah, just I think I have a final slide if I can reach it. Yes, with our contact details. So yeah, you can see on the screen now all our contact details from our different sales team if you wish to contact one of them. And you can also see the link to find out more about our larger network of distributors. And also you will have a short survey that will appear at the end of the webinar asking if you wish to be contacted by a salesperson. So thanks again for joining us today and talk to you soon. Bye.